This is lessons 12.3 and 12.4, volume of cylinders, pyramids, cones, and spheres. So in this table, we have all of the volume formulas, including volume of a prism that we've already seen, and then volume of a cylinder, pyramid, cone, and sphere. Some things to notice about these formulas. If you look at the similarity between the prism and the cylinder formula, notice that the big B for a prism in a cylinder has been replaced with pi r squared, which makes sense because the base of a cylinder is a circle, and the area of a circle is pi r squared. You see the same similarity between the pyramid and the cone formulas. Notice the big B here for a pyramid has been replaced with pi r squared for a cone, because again, the base of a cone is a circle. So these are the formulas that we will use to find volumes in this section. Okay, so the first few examples are pretty straightforward. We're just finding the volume of a figure, and it's just one single figure. So for the first one, this is a cylinder, so we'll want to use the formula for volume of a cylinder, V equals pi r squared h. And then we just need to make sure we put the numbers in the right place. So pi times radius, which is 2.2, squared, times height, which is 4.5. And then you should be able to put this in the calculator from here. And you should get, rounded to the nearest tenth, 68.4 cubic feet. And for part B, this one is a pyramid. So we start with the pyramid formula, V equals 1/3 BH. And then remember, every time we see this big B, we need to replace it with the formula for the area of the base. Well, if I look at the base here, I see that this is a square. So we could replace this big B either with length times width and treat this like a rectangle, or we could acknowledge that these are the same and it's just a square and replace the big B with s squared, which is just the side squared for area of a square. Either way, we'll have this exact same result. So if we want s squared h, so side squared, sides of the base, squared, times the height. So V equals 1/3, and the sides are each 7, and then the height is 6. And again, we'll put this all in the calculator, and we should get approximately 98, or actually exactly 98 cubic feet. Okay, let's go on to the next one. This shape is a cone, so we'll want the formula for the volume of a cone. That's V equals 1/3 pi r squared h. So replace the r with the radius, 4.3, and then the h with the height, which is 11, and then use the calculator to evaluate that. We should get a volume of approximately 213 cubic meters. And for the last one, this is a sphere, so we'll use the formula for volume of a sphere, V equals 4/3 pi r cubed. And make sure you get that this is cubed here, don't accidentally do squared. And the only thing to substitute here is the radius, which is obviously 5. And if we put this in the calculator, 4/3 times pi times 5 cubed should have a volume of 523.6 cubic inches. Okay, at the top of the next page, there are 4 similar problems for you to try on your own, so pause the video and find the volume of each of those. When you're ready to check your answers, go ahead and press play. Okay, for this first one, this is a cylinder. It has a volume of approximately 326.9 cubic feet. The pyramid for B has an approximate volume of 81 cubic inches. For C, this cone has a volume of approximately 1.1 cubic meters. And the sphere for D has a volume of approximately 268.1 cubic meters. Okay, the next pair of examples involves composite solids. These are solids that are made up of more than one single solid. So just like we did with composite figures to find area when we talked about two-dimensional shapes in chapter 11, for these we'll do the same sort of idea of just adding the various volumes together. So in this first figure, what I see is 3 different cylinders. So I have a cylinder plus a cylinder plus another cylinder. So then the volume for each of these is pi r squared h. And obviously each one will have a different radius and a different height. Okay, so let's start at the top. The radius of the top cylinder is 5 and the height is 5. So that's 5 squared times 5. For the second one, the radius is 7.5 and the height is 7. And for the last one, the radius is 10 and the height is 9. Now, I like to find the volume of each of these separately and then add them together. You can do it in one step if you put it all in the calculator at once, but it's a little bit better to find each one separately. That way, if you made a mistake, you can go back and check each one individually. So this is 392.7. This one is 1237, and the last one is 2827.4. And when we add them all together, we get a combined volume of 4,457.1 cubic inches. For this next one, this looks like a fairly complicated figure, but again, we'll break it down into familiar shapes. So I see on the bottom here we have a rectangular prism, and then on the top I see 2 triangular prisms, and if we check those dimensions, this would also be a length of 5, because 5 plus 2 plus 5 would give me 12, and this would also have to be a height of 3, and they both have the same depth. So I can actually group those together and say we have 2 triangular prisms, since they would both have the same volume. And the only other thing we need is this little rectangular prism that's between those 2 triangular prisms. So that's another rectangular prism. Okay, so the formulas we need for each one. For a rectangular prism, we know we use area of the base times the height, and since the base is a rectangle, we can replace that with length times width. So for a rectangular prism, length times width times height. And then we have 2 of the triangular prisms. And again, volume is area of the base times the height. And for a triangle, the area of the base is 1/2 base times height. So here's the area of the base times the height. And then another rectangular prism, same formula, length times width times height. Alright, let's go ahead and substitute numbers in, being careful to make sure that we put the right numbers in the right place. So this is the large rectangular prism. It has a length of 12. It has a width of 3. That would be the same width as this part up here. And it has a height of 3. So 12, 3, and 3. For the triangular prisms, the base and the height of the triangle, we have a base of 5 and a height of 3. And then the height of the whole prism, remember that is the distance from one base to the other. So it's from this base at the front to the base, the triangle in the back, and that is 3 meters. Okay, and then for this little rectangular prism, we have a length of 2, we have a width this way of 3, same width here, and a height of 3. So this is 2 times 3 times 3. And again, I'll evaluate each of these separately so that we have each of the volumes individually before we add them together. So here, 12 times 3 times 3 is 108. And then 2 times all of this is 45. And then 2 times 3 times 3 is 18. When we add those all together, we get a total volume of 171 cubic meters. Okay, at the top of the next page, there are 2 similar problems for you to try on your own. So pause the video and find the volume of each of those. When you're ready to check your answers, go ahead and press play. Okay, for this first one, we get an approximate volume of 3895.6 cubic centimeters. And if you didn't get this, just a few things to make sure that you have in your formulas. First of all, make sure that this shape down here, this part, this should be half of a cylinder. So make sure that you divided that volume in half instead of getting the whole cylinder. Also, notice that this is the diameter. So when you plug that into the formula, you cannot put in 12 because the formula uses the radius. So if you didn't get this answer, those would be some things to check to make sure that you had those correct. For part B, you should get a volume of approximately 2.8 cubic meters. And for this one, the most likely thing I can think of, if you didn't get this answer, the most likely thing I can think of is maybe using the incorrect height for the triangular prism. A lot of times we get confused between the height of the base versus the height of the prism. Remember, that's the distance from one base to the other base. So that should be this distance right here. So again, if you didn't get 2.8, that would be a thing to go back and check. All right, let's look at the last example. This says a beach ball has a diameter of 18 inches. A hand pump will inflate the ball at a rate of 325 cubic inches per minute. About how long will it take to inflate the ball? Round to the nearest tenth. Okay, so here we're filling the ball with air. So we are talking about volume. So instead of talking about a ball, we want to use the formula for the volume of a sphere. So V equals 4/3 pi r cubed. Now we're given the diameter is 18 inches. So we want to divide this by 2 to get that the radius is 9 inches. So V equals 4/3 pi times 9 cubed. And if we use the calculator to evaluate this, we get an approximate volume of 3,053.63 cubic inches. Okay, so this is how much air fits in the ball. This is not the answer to the question, though. We want to know how long it will take to inflate the ball if it inflates at a rate of 325 cubic inches per minute. Okay, so, and remember, way back, if you have trouble figuring out whether to multiply these or divide, you can always use dimensional analysis. So we have 3053.63 cubic inches. And always put that over 1. And then we have 325 cubic inches per minute. So the cubic inches need to cancel out with these cubic inches, so we need those on the bottom. 325 cubic inches per 1 minute. And now the cubic inches cancel, and now we can see that we actually want to divide these. So 3053.63 divided by 325 should give you approximately 9.4 minutes. Alright, the try it yourself problem is very similar, so go ahead and pause the video and work through that last problem, and when you're ready to check your answer, go ahead and press play to continue. Okay, for this one, how long will it take the ball to deflate if it leaks at a rate of 100 cubic inches per hour? Should have gotten approximately 335 hours.